In this video, we are going to review projectiles off a cliff. In this lesson, we are combining two earlier lessons, our physics of war projectiles lessons and our Thelma and Louise lesson which dealt with horizontals off a cliff. Therefore, before watching this video, I strongly recommend that you review the two previous videos which make the foundations for this video. If you understand those videos, this video here will be not too challenging. So, let's take a look at my first question. A skier traveling at 20 meters per second skis off a 15-meter cliff at an angle of 60 degrees to the vertical. Find the skier's time in the air. Find the range of the skier. And what is the skier's velocity at 2.5 seconds? So let's first look at this here. Here's my little mini diagram. We're going off cliff 15 at 60 degrees from the vertical. That means I want to know this part here, which is 30. Okay, and we're going to break it down into two sections. If I look at this here, my first section is this part here, going to that maximum. This here is my physics of war part. That's the projectiles. Actually, all the way to here is the physics of war part, but we're only going to go to that part there. The reason why is because from here down, this is now our Thelma and Louise question. Once we hit the maximums, our Thelma and Louise question. Because then once we hit this maximum point up here, my velocity in the y at that time is 0. We have an x velocity because our x velocity never changes, but our velocity in the y will be 0. And that's a key thing, so we're going to break this down to two different main steps. So first, whenever we have vectors, we always must break them down into x and y. So let's take a look at this. We know Vx is equal to 20 cosine 30, okay? Which is equal to 17.2 meters per second. We know my velocity in the y is equal to 20 meters per second sine 30, which is equal to 10 meters per second. All right, so now we have those down. Let's take a look at my A. It says, find the skier's time in the air. So we want the whole time in this air here. So we're going to actually want to do my first part, which is my physics of war. So let's break it down to my y to get my time to the maximum height. So here we know my Vyi is equal to 10 meters per second. We know my acceleration is equal to negative 9.81 meters per second squared. My distance, we do not know. We know my final velocity is equal to 0 at this point here. And we know my time is also what we're trying to figure out first. Okay? So let's try and solve this. All right, so our first equation we're going to use is going to be this one right here, where we have Vf is equal to V velocity, initial velocity, plus acceleration times time. Well, we know my final velocity is equal to 0 at that maximum height. So we could just cross that off. Now we're going to rearrange this for time. So I'm going to get negative Vi, initial velocity, divided by my acceleration is equal to my time. Okay? So we look at this. I'm going to have negative 10 meters per second divided by negative 9.81 meters per second squared is going to be equal to 1.02 seconds. So now we know the time to get to this point here is 1.02 seconds. Okay? Now I want to figure out the time for the rest. Well, if I look at this, this is now just the Thelma and Louise question. It's the same idea as if I drop my pencil. We just need to know how long it'll take to go down there. But before I do that, I have to know what is this maximum height. Okay? So before we even get to the Thelma and Louise part, we still have to do our physics of war part and find the maximum height. So for that here, I'm going to look at this formula here. We're going to have my final velocity squared is equal to my initial velocity squared plus 2 multiplied by my acceleration multiplied by my distance. So if we rearrange that, I'm going to end up getting, well, we know the final, or the initial velocity, or the final velocity for this one is 0. So we're going to rearrange this. I'm going to have negative 2AD is equal to V squared. We divide by 2, so my distance is equal to my initial velocity squared divided by negative 2 times my acceleration. Okay, we're going to just plug in our numbers here quickly. I'm going to have, we have 10 meters per second, and this must be squared, and that's going to be divided by 2 multiplied by negative 9.81 meters per second squared, and that's going to end up giving me a total of 5.1 meters. All right, so now I know my total height here, if this is 5.1, my total height is going to be 20.1 meters. Now with that, now I could finally use my Thelma and Louise examples where we go horizontally just off a cliff. Same idea as just dropping this pencil. Okay, so let's find this little bit of time there. So in this case, we know my distance, right? So we know my distance now is equal to 20.1. So here we have distance is equal to, I'm going to use the formula VIT plus 1 over 2 acceleration times time squared. Now, in this case, this is now our blue section with the Thelma and Louise. My initial velocity now is 0 when we're looking at the Thelma and Louise, because at the very top, my initial velocity is 0. So this is going to cancel out. Same thing, if I drop this from here, I just need to know the time it gets down. My initial velocity will be 0. So we have my distance is equal to 1 over 2 acceleration times time squared. We rearrange that, I'm going to end up getting 2 times distance divided by acceleration, square root, is equal to my time. Okay? We're going to continue this here and plug in, so I get 2 times 20.1 meters divided by my acceleration is 9.81 meters per second squared, and we want to square root that. I'm going to end up getting a total of 2.04. Now, we want to combine this with my time before to find total time in the air. So I'm going to add 1.02, which gives me 3.0, that's 2.02 seconds, which gives me 3.04 seconds. So this here is my total time. So now we answered A. So in A, total time is 3.04 seconds. Okay? So now let's look at my next part. It wants to find the range of the skier. Well, now we're just going to look at the x. His velocity never changes in the x. It's always the same. So his velocity is always going to be 7.2 meters per second. So we're looking here, dx is equal to my velocity in the x times by my time. In this case, my distance in the x is equal to 17.2 meters per second multiplied by 3.04. This is going to end up giving me 52.3 meters. Okay, so now we have B. Okay, the range of the skier is 52.3 meters. Okay, now we're just going to have to find C, which is my time. So what is the velocity of the skier at 2.5 seconds? Well, we know it takes 1.2 seconds to go here. My x is always the same. But now, at 2.5, so I want to know at 1 1.48 of the Thelma and Louise, what is their velocity in the y? If I could find the velocity in the y at 1.48, all I did was, 1.2 2.5 minus 1.2 gives me 1.48. So 1.48 into the Thelma and Louise scenario here with the horizontal off the cliff, then I could find my resultant velocity. Okay, so how do I do that? We're going to just do the same thing here, except now we know the time. So once again, we're starting to do C here. I'm going to have, just give me some room. Okay, so we're going to have here, I know that VF is equal to AT, acceleration times time. Now my acceleration is negative 9.81 meters per second, and we want to multiply that by my time, which is, in this case, we said 1.48. And that's going to give me a total of 14.5 meters per second. So my y, my final velocity in the y, is equal to that. So at this time, at 2.5 seconds, it is going down at negative 14.5 meters per second. We know my Vx is still 17.2. So if I was to make this and look at this here, again, all I'm going to do is, we know we go down at 14.5, and then we're going over at 17.2. So my angle, my resultant, should look like that. So once again, I just have to use the Pythagorean Theorem to figure that out. So I'm going to go right back down here, and we're going to look at this Pythagorean Theorem here. So in other words, we know my resultant squared is equal to x squared plus y squared. In this case, it's Vx and Vy. Okay? So my Vx and Vy are 14.5. meters per second squared, and my Vx is 17.2. Okay, now we want to add these together, and we square them, which is going to end up giving me 22.5 meters per second. So now we know my velocity resultant is 22.5 meters per second. But we also need to know the angle. So to use the angle, I'm just going to have to use trigonometry. So theta, in this case, we're going to have to use tan. So remember Sir Coxeter, so tan. And that's going to be y over x. So in this case, we're going to have to use the inverse of tan. So, and that's 14.5 divided by 17.2. And that's going to give me a total of 40 degrees. Okay, so C, it is going to be 22.5 meters per second at 40 degrees below the horizontal. Okay. So that is the basics of how we solve these questions of projectiles off a cliff. We must break it down into our parts. So we first go and we're looking at the projectile part. Once we're done quite a bit with the projectile parts, then we're looking at the Thelma and Louise part, and we do our calculations there.